Greeting, ladies and gentlemen. Today we're going to continue our session into question 3. So, the solid shaft shown in form of a brace for which the allowable shearing stress is 55 megapascal. Neglect the effect of stress concentration. Determine the smallest diameter DAB and DBC for which the allowable shearing stress is not exceeded. Being given answer for the first one, that will be 42 millimeter, and the second 33.3 millimeter. So essentially, there is an object right here, solid cylinder shaft AB and BC. For the material of AB, both of it have a same shearing stress, which is 55 megapascal, but the difference is its diameter, which is DAB, which is shaft AB have a diameter different than the BC. So the question asking what is the diameter for both of it. So let's go to the problem solving. So this is the free body diagram for the wall system. Remember, before you begin your solution, first thing first, you need to draw your FBD. So for the FBD in here, I had draw the wall object cutting from its support. So you will have a T prime C, you will have a TB prime, and you will have a T prime right there. T prime C is referred to internal torque at point C, as the internal torque, the torque being applied on point C, it is 400 Newton meter. If you look from this point of view, the torque being given exerted downward. But when we're talking about internal torque, the direction that will be different but have the same magnitude. Remember, we were using this equation. In this equation, the value of torque in here that must be in internal. So you need to convert this applied torque into its internal value. So in this case, torque prime C have a direction. If you take a look in the front view, upper side, then have a same magnitude. For the torque prime B, as the applied torque, that will be upper side from this front view, then its internal torque that will be in a different direction, which is downward. And for the torque prime, I'm assume that will be downward. So for the problem solving, I am using this equation. It is being called as shearing, elastic torsion formula. So you will have a tau equal to torque prime CAB over by J. J is referred to polar moment of inertia. It depends on the shape that you were using. In this case, it is a solid cylinder. So the value of polar moment of inertia, that will be pi over by 2 C to the power of 4. The value of CAB, that will be, in this case, is radius for AB. This shaft, and been given the tau, which is allowable shearing stress, not exceed 55 mega. So this object will not fail as long as the shearing stress is not exceeded 55 megapascal. So this value we will abuse in calculation. So you have J, you don't know what the value of C, which is what is the question asking us, the diameter of AB. So we don't know what is the value of C, but we did know the value of tau. So there is only one unknown. You simplify this equation, which is the original equation will be tau prime CAB over by J, which is J equal to pi over by 2 C to the power of 4. But you simplify it, so you will get this equation, tau prime equal to pi over by 2 C to the power of 3. So you insert all the data that been given, which is 0.8 kilonewton. It is come from the minus of 1.2K by 0.4K, which is this torque need to be minus by this torque because the direction were different. I'm assume downward as positive, so you will get 0.8 kilonewton for torque prime. Thus, you insert the value, then you will get the value of C for AB. Radius for AB, shaft AB, which is 0.021. Since it is radius, then you need to times it by 2 to get diameter. So you will get 0.042 meter. Convert into millimeter, that will be 42 millimeter. So that is for the question 1. Now we onward into the second question, which is diameter for BC. In here, diameter in here. So we cut from C to B, and you will have only a single torque, which is 0.4K, being applied at point C. But since we were using this equation, thus the value must be in internal. That's why we were using internal torque at point C, which is 0.4K, but in a different direction, which is upward. So you do the same procedure, then you will get the value of C, which is 0.0167 meter, which is the radius. You times by 2, you will get 0.0333 meter, then convert it into millimeter. So I think that's all for today. Thank you for watching and have a nice day. Bye bye.